Hello everyone, welcome back to another lecture of building estimate, how to calculate the quantities of different item of works. So students, we have covered long wall short wall method, center line method, and we have just started the conceptual learning or the fundamental learnings of the reinforcement calculation. We have seen around 10 fundamentals of reinforcement calculation, and we have calculated for RCC beam, in which we have found out the weight of the reinforcement bar or the total quantity of the reinforcement work. So now today in this session we are going to learn numerical based on RCC column. Let us start with the question. So calculate the following quantities from the figure of RCC column. First, excavation and PCC for the column footing, cement, concrete and formwork for column footing and column, and reinforcement steel for column footing and column. So three things we need to find out in this numerical. Now let us see the plan and the section of RCC column. So as you can see here, this is the plan and the section of an RCC column. First, if you see the section, the bottommost part is having the width 1.30 meter. This 1.30 meter, student, is the width of the excavation and PCC. As you can see, just above that 1.30, that thick PCC is shown. Now above that, that is column footing. This column footing is of having width or the base as 1 meter. Now that is a slope footing. So there is a different height, that vertical height, then slope height, then again the vertical height is being given in the section. The original column is of about 30 cross 30 centimeter. The reinforcement details are also given in the drawing. The vertical reinforcement is of 16 mm diameter and there are 4 numbers of bars. At the bottom level in the column footing, there is 12 mm diameter of reinforcement bar having center to center distance of 10 centimeter. Now there are lateral ties given of 8 mm bar. Center to center distance is 15 centimeter. The height of the column above ground level is 3 meter and the slab thickness is 10 centimeter. Now if you look at the bottommost portion of the section, there is a cover of 2.5 centimeter at bottom and 2 centimeter at top. Now for the horizontal reinforcement, there is another gap of 2.5 centimeter is being provided. So total 5 centimeter is left from the bottom. Now as you can see in the drawing, the vertical reinforcement is having L shape and that extra length of the L is 0.3 meter. So this is our RCC column, for which we need to find out 3 quantities: excavation and PCC for the column footing, concrete and formwork for column and column footing, and steel reinforcement quantity for that column footing and the column. So starting with our first quantity, which is excavation and PCC, let us see. So as we have already discussed just in the section explanation, that bottommost part for the excavation was 1.30 and if you have seen the section very closely, that is the square column. The column which we are working on, it is the square column. So the length and width will be 1.30 cross 1.30. In numbers, I have written 1 because it is only one column. Now the height. Let us see the section again. So excavation depth is the depth below the ground level. So adding the separate heights below the ground level, 0.5 plus 0.5 plus 0.4 and 0.15. So we'll get 1.55. So in the column of H, I have written 1.55. So we'll get the excavation quantity as 2.62 cubic meter. Now for the PCC. Students, we have been already learning this concept from the method of central line and method of long wall and short wall, that PCC is being done in the area which you have excavated. So numbers, length and width will be the same as excavation, only PCC thickness or PCC height will be changed. Here in our case, PCC thickness is 0.15. So we'll get the PCC quantity as 0.25 cubic meter. So this is up to this point, it is very easy and it is very clear. So now moving forward with our third quantity, that is concrete work in column footing and column. Here the column footing is in the trapezoidal shape. So the column and the column footing is divided into number of parts and quantity of each part is being derived. So first part is extreme bottom portion of the footing and which is straight, having no slope, the extreme bottom of the footing. Let me explain you first the parts of the footing. So here, as you can see in the section, the first bottommost part, which is like the straight part, this, then the second is trapezoidal, then again the straight part up to ground, and the fourth part is above the ground level. So coming back to the calculation, fourth part is extreme bottom part of the footing. Now that dimension is 1 into 1, that is a rectangle square column, so it is 1 into 1, and the height of that portion is 0.4. Now talking about second part, which is trapezoidal in shape. So we know the formula for the volume of the trapezoidal, that is h by 3 into a1 plus a2 under root a1 plus a2. So that is how we'll get the volume as 0.232 cubic meter. Now the third part of the concrete work, where the concrete work is going to be done, is again the straight part but above the trapezoidal. At that point the column size is 0.3 cross 0.3 and the height is 0.50, and the last part is just above the ground level. At that point the column is also of 0.3 cross 0.3 and height is 3 meter. Here in trapezoidal shape, A1 is the top square area. So if you look at the trapezoidal shape, the top portion is of 0.3 where the column is being reduced. A2 is the bottommost portion, so that was of 1 meter. So A1 0.3 into 0.3, area, it is area, so square 0.3 into 0.3, and the bottom area 1 cross 1, and the height of that vertical portion is given in the section drawing. So I hope we are clear about the concrete and will get the total quantity as 0.95 cubic meter, or you can round it off by 1 cubic meter. Now let us see the formwork. Now for the formwork, again, as you know that the column footing is of trapezoidal shape, so we need to divide the entire drawing into 4 parts: the extreme bottom, the trapezoidal, above trapezoidal, and above ground level. So starting with the extreme bottom portion. Now here in the column of numbers I have written 4. Why? Because the column is a square column. So there will be 4 sides of a square. So we need to provide formwork from all the sides. So numbers will be 4. In the section, you are only seeing this one side, but column will be here, 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 and at the back. So there will be 4 sides. I hope they are clear about the number. Now, this extreme bottom part is having width 1 and height 0.4. So we'll get the quantity of that extreme bottom portion as 1.60 meter square. Now, talking about the trapezoidal portion, the area of that trapezoidal portion is A plus B into L by 2, where L is the slant length of the trapezoidal. Now, to get the slant length of the trapezoidal, let us understand this figure. So as you can see in the figure, the bottom portion was of 1 meter, the top portion was of 0.3 meter. Now, if I apply this 0.3 meter at 1 meter level line, the remaining portion will be 1 minus 0.3, 0.7. Now, this vertical line which I have drawn, it is divided into 2 triangles. So 0.35 this side and 0.35 this side. So if we have get the right angle triangle, by the Pythagoras theorem, we can get the slant length. So slant length will be L equals to 0.61 meter. Now A and B, top dimension and bottom dimension, 0.3 and 1. So we have all the values, and by applying those values, we'll get area as 0.39 meter square, or nearly as 0.4 meter square. But again, remember, this trapezoidal is on the 4 sides. So we'll get the total formwork quantity for that trapezoidal as 1.60 meter square. Now students, you might have a question here that in general practice, there is no formwork provided at such trapezoidal shape footing or the slope footing. In such cases, or in the such practical at site, the hard concrete or the stiff concrete is being placed and get into the shape of the slope as by the help of different floaters or different finishing levels. But here we are calculating the formwork quantity as a standard practice. But in general real-time practice or in many sites, there is no formwork provided at the trapezoidal portion. Instead of that, the stiff or the hard concrete, the concrete having water ratio very low, is being poured at that portion, and it is being finished with the various finishing tools. Now, moving forward, the next part is part of the footing above trapezoidal up to ground level. At that point, the column is 0.3 cross 0.3, and in height it is 0.5. So width and height will be the component for the formwork, as formwork is the meter square quantity. Numbers are always 4. So we'll get the quantity as 0.60 meter square. Now the last portion is above the ground level. At above the ground level, the height is 3 meter and the width is 0.3. So we'll get the quantity again as 12.6 meter square. So total formwork quantity will be 16.4 meter square. So I hope we are clear up to this point. Now moving to our last quantity, very important quantity, steel reinforcement work. In steel reinforcement work, first let us calculate for 16 mm vertical reinforcement, which are 4 in numbers. So I have already written 4 in column of numbers. Now let us discuss the length. Now, as we are talking about the vertical reinforcement, let us see the section again. As you can see in the section, let us consider all the vertical heights. So adding up all the vertical heights, 0.4 plus 0.5 plus 0.5 plus 3 meter. That is entire vertical height of the column. But as we already know that column or the reinforcement of the column is being placed after the deduction of the cover distance. So deducting the cover distance 2.5 centimeter from bottom. Now, as you can see again in the section, there is 2.5 centimeter gap for the horizontal reinforcement. So deducting that 2.5 centimeter again. The top cover is of 2 centimeter. So deducting that 2 centimeter. Here plus 0.3 should be done as the reinforcement bar is banted in L shape. So that L shape length is 0.3 and this vertical reinforcement is 180 degree, having 180 degree hook at both the ends. So we need to add 18D. So as we have just seen in the figure, these are the calculation that all the vertical heights 0.4 plus 0.5 plus 0.5 plus 3 meter plus 0.10, that was slab, because the vertical dimension, vertical reinforcement was going up to the slab. Deduction of the bottom cover, deduction of the bottom gap, deduction of the top cover, plus that L-shaped length and plus that hook length at both the side, 18D. So we'll get the length as 5.18 meter. Now in the section, if you look at closely, the weights are already given. So here you don't have to do d square by 162 math process, because here in the drawing itself given that for 16 diameter bar you have to take 1.60 kg per meter. So we'll get the weight for 16 mm diameter as 32.12 kg. Now moving forward, the next is 12 mm horizontal bars at the bottom level, which is having 10 centimeter center to center distance. First, we need to find out numbers of bars. So as we know that number of bars is equals to span of bars divided by spacing plus 1. Here, the horizontal width of the column is 1 meter. Now, there is in 5 centimeter cover, side cover at the both side. So, deducting this 5 centimeter from the both sides, so 10 centimeter 0.1. So, span will be 0.9. The center to center distance is 10 centimeter. So, putting up all the values, we'll get number of bars as 10. But generally in footing, these bars will be from both the ways. So as you can see in the section, the dots are, if this is the reinforcement, you are seeing these dots. So this kind of dots will be on the other side of the footing. So numbers will be doubled. So 20. Now talking about the length, as we already know that span is your length. So 1 meter minus 0.1, but again, these horizontal bars are also having 180 degree hook at both the ends. So plus 2 times 9D. So we'll get the length as 1.12 meter. So 20 numbers, 1.12 meter, and the weight is 0.90 kg per meter. So we'll get the quantity for this 12 mm as 20.60 kg. So I hope we are clear up to this point. Now, moving forward, the last part is calculation of 8 mm lateral ties having 15 centimeter center to center distance. First, let us calculate the number of ties. So, number of ties is span of ties divided by spacing plus 1. So, the span will be 0.4 plus 0.5 plus 0.5 plus 3. Here I have not included the slab because at slab there will be no vertical tie of column. There will be the reinforcement of the slab. So only 3 meter up to 3 meter height is considered. Now out of this plus height we need to deduct that bottom cover, bottom gap for horizontal, and we'll get the span as 4.35 meter. Spacing is 15 centimeter. So we'll get the number of ties as 30 numbers. Students, as we have already discussed in the previous session that for beam it is the terminology is stirrup, for the column it is lateral ties, but ultimately both are the same. Now let us calculate the length of this stirrup or the lateral tie. So we know the formula 2a plus 2b plus 12d or 0.15, whichever is greater. Now to find out the value of a, we know that the total dimension of the column minus cover minus 2 times the diameter of the stirrup or the lateral tie. Here value of a and b will be the same because this is the square column, so both the dimension is 1 meter or 0.3 meter. 1 meter is for the footing, but we are talking about the column, so column is 0.3 meter. So we'll get the length as 1.09 meter. We have numbers 30 and the weight for 8 mm is given in the drawing as 0.40 kg per meter. So we'll get the quantity as 13.08 kilogram. Again, let me remind you that you don't have to add up all this quantity. You have to keep the separate quantity diameter wise as I have represented here. So I hope we are clear in the quantity calculation of RCC column. So this is it. That was all about in today's session. I hope we have learned it very well. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.